In Unit 13, Part 2, we are talking about simplifying square roots. I think this is a pretty difficult concept, so if you have questions, make sure to be asked. I'll do my best to explain it in the video, but if you need any help, do ask. All right, so it says a radical expression is in simplest form when. So there's two things that have to happen here. No factor of the expression under the radical has any perfect square factor other than 1. So perfect square factor means there's no numbers that go into it that are perfect squares. And then the second thing, there are no fractions under the radical sign and no radical sign in the denominator of any fraction. So you can't have a fraction under the radical sign, and you can't have a radical in the denominator. So there's a couple things to remember there. So let's look at the product property of square roots. So in your book, it tells you that if you have the square root of a times b, the product property says that you can split that up into the square root of a times the square root of b. So looking at it as actual numbers, if I have the square root of 9 times 7, I could split that into the square root of 9 times the square root of 7. The reason why we would do that is, for this example, if I have the square root of 63, I could split that into 9 and 7, and then 9 has a square root, which we'll get to that in a second. But that's the product property. So it says simplifying a radical expression. I'll do a few examples, and then I'll leave a few for you to try. Again, these are not the easiest things in the world, but just do your best. So for number 1, it says the square root of 98, so we want to simplify this. What we're trying to do is pull out the biggest factor. Again, factor are numbers that go into something. Biggest factor that is a perfect square. That's what we're looking for. So if you think about the factors of 98, you have 1 in 98, you have 2 in 49, and that's all that goes into 98, I believe. Either way, I know that I'm done because I found 49 right here. 49 is a perfect square. So I'm going to take the square root of 98 and split it up into the square root of 49 times the square root of 2. Remember, that is the product property that we talked about right up here. I can just split it into the two numbers that go into it. So I take the square root of 98, I split it into the square root of 49 times the square root of 2. The square root of 49 is 7, so that comes outside the square root now. 2 does not have a square root, so that stays underneath the radical. And then this is simplest form. So let me rewrite that in case that's hard to read. So 7 square root of 2 is the simplified version. Okay, so again, we want the biggest factor that's perfect square. For 48, I know that I have 1 in 48, I have 2 and 24, I have 3 and 16, I have 4 and 12, and I have 6 and 8. So those are all my factors of 48. I want the biggest perfect square. So 4 and 16 are both perfect squares, but obviously 16 is the biggest one. So I'm going to split 48 into the square root of 16 times the square root of 3. The square root of 16 is 4. 3 does not have a square root, so 3 stays underneath the radical sign. So 4 on the outside, 3 underneath. Number 3, I'll leave for you guys. My only hint will be to think about money, think about quarters, figure that one out. For 252, I want to show you something else that you'll see. So say I don't know all the factors or something, or I don't want to take the time to find all the factors, I can go ahead and split this. So for 252, I know that 4 and 63 are factors of 252. Now 4 is a perfect square, so I know that's going to become 2. But if I look at 63, I need to decide, because if you go back up to our rules, no factor can have a perfect square other than 1. If I think of 63, I know that I have 1 and 63 as factors. I have 7 and 9 as factors. Okay, so looking at that, I can see that 9 is a perfect square. So that means 63 would have to be split into the square root of 9 times the square root of 7. 2 stays on the outside still from the square root of 4. The square root of 9 is 3, and then I have the square root of 7, which does not have an actual square root. So now I can do 2 times 3 and get 6, and leave 7 under the square root. So I show you that because if you don't necessarily know what the biggest factor is of the perfect square, or you don't know how to get it, you can start somewhere else. You just have to make sure you simplify it all the way down. 112 only for you guys. Again, remember you're looking for a perfect square that goes into it. For 43, a couple ways I can do this. First off, I could split this into 81 and 3. If I do that, the square root of 81 is 9. 3 doesn't have a square root, so I'm done there. 9 root 3. But again, let's say I didn't know that 81 goes into 243, but I did figure out that 9 goes into it. So I could have done the square root of 9 times the square root of 27, because 9 and 27 are factors of 243. The square root of 9 is 3, and then 27 I would have to split into the square root of 9 times the square root of 3. So I have 3 times the square root of 9 is 3 times the actual square root of 3. So I would multiply the outside 3's together and get 9, multiply those two together, and then leave the last one inside. So either way, I get the same answer. So try number 3 and 5 there. Again, if you need help, let me know. I understand this is not the easiest concept in the world. So moving down, we're going to simplify variable expressions that include that have radicals. So if you look, I have square root of 24x squared. So I need to split this into the factors that are perfect squares. So I know I can split 24 into 4 times 6, and then I'll also have the x squared. So again, that's just your product property of radicals. I'm just splitting everything up. I chose 4 and 6 because I know that 4 is a perfect square. So the square root of 4 is 2. There is no square root of 6. The square root of x squared is x. So the numbers that are outside the radical go together. So I get 2x. The number that's inside the radical stays inside. Let's look at number 2. I'm going to split 54 into the square root of 9 times the square root of 6, and then I have the square root of b to the 4. Again, I chose 9 and 6 because 9 is a perfect square. The square root of 9 is 3. There is no square root of 6. The square root of b to the 4th is b to the 2nd. Okay, because the square root of 4 is 2. So basically, I have square root of even x. So I can multiply the 3 and the b squared together because they're on the outside. And then the square root of 6 will stay on the inside. Looking at our last example, I'm going to split 120 into the square root of 4 times the square root of 30. Then I have the square root of 8 squared. That's the square root of j. So now I chose 4 and 30 because I know 4 is a perfect square. So the square root of 4 is 2. There is no square root of 30. The square root of 8 squared is 8. There is no square root of j. So 2 and h can go together because they're on the outside. 30 and j can go together because they're both underneath the radical. So that would be my simplifying. On the back side, we're talking about the quotient property of square roots. So if I have a radical and I have a over b, I can split that into the square root of a over the square root of b. So just like we did with the product property, but now we're talking about division, we're talking about fraction. So say I had the square root of 9 over the square root of 16, I can split that into the square root of 9 over the square root of 16, which, if I work those out, would be 3 over 4. Okay. So let's look at some examples. For number 1, I have the square root of 15 over 16. So the first thing I want to do is split that up. So square root of 15 over square root of 16. 15 does not have any factors that are perfect squares, so I leave that the square root of 15. On the bottom, the square root of 16 is 4. So that's my final simplified version. For the second one, again, I'm going to start by splitting it. So square root of 32 over the square root of n squared. For 32, my factors are 1 and 32, 2 and 16, and 4 and 8. So I want the biggest one with the perfect square, which would be 16. So 32, I'm going to split into the square root of 2 times the square root of 16, and that's still over the square root of n squared. So the square root of 16 is 4. There is no square root of 2. The square root of n squared is n. So I'm simplifying there. For number 3, okay, another pretty tough example. Again, I start by splitting it to the square root of 48y squared over the square root of 25. So for 48, my factors are 1 and 48, 2 and 24, 3 and 16, 4 and 12, 8 and 6. So 16 is my biggest perfect square. So I'm going to split 48 into the square root of 16 times the square root of 3, and then I have the square root of y squared. The square root of 25 is 5, so I'm going to go ahead and put that down. The square root of 16 is 4. There is no square root of 3. The square root of y squared is y. That's all over 5. And then 4 and y can go together because they're both outside the radical, and then you say under the radical. So that's my fully simplified version. Alright, the last part is some review problems. Please make sure you get those done. If you need any help with those, just let me know.